Hey guys, welcome 1.8 video. We're talking about perimeter, circumference, and area. This should all be basic review stuff. So let's get into it, but these formulas are going to be muy importante. First of all, we don't have to write this down, but perimeter is the sum of the length of its sides, so we'll get formulas for this. And area is the number of square units it encloses. Okay? So we can write those down, but I hope we understand perimeter is the outside of the shape, distance, and area is the shape or the amount of area or space inside of the shape. And we usually quantify those in what are called square units. So the unit could be meters, feet, inches, things like that. Okay, what you do have to write down for our notes today is all of this. Okay. So we have to know the area for a square, which is simple, side times side or side squared. And the perimeter, you just add them all up. So even if you don't know the formula, you can still get away with doing it. This one a little bit more important, triangle, 1/2 base times height. If you actually look at this picture, I'm going to cheat, you don't have to draw this, but if I were to complete this picture, you see how it looks like a square? Basically, it's the same formula. Square rectangle, it's the same formula as a rectangle, base times height, but it looks like half of it, and that's why you take half. So there's that piece, and then our distance around it would be a plus b plus c, so there's no formula, it's just adding the sides up. Rectangles, opposite sides are congruent, so that helps in doing a formula for perimeter. You can just do 2 times the base plus 2 times the height. Again, you can just add all 4. And then base times height gives you the area. And circle has the most specific one, and that would be circumference could be pi times the diameter, or 2 times the radius times pi. If you think about it, 2 times the radius is the same as the diameter, so those are equivalent. And then our radius, or sorry, area is going to be pi r squared. Let's look at some examples. Alright, let's take a look. This is our first example, number 1. Write it down. It says you want to frame a picture that's 5 by 7 with a 1-inch wide frame. What is the perimeter of your picture? Okay, so we have to draw our picture out here, and this is going to be 5 by 7. Okay? Now, it tells you have a 1-inch wide frame. Okay? So you want to frame a picture that's 5 by 7. What's the perimeter of the picture? So you have to read carefully. Does it ask us the perimeter of the frame? No. We could add on 1 inch all the way around, and that would increase our perimeter. Okay? But it just asks for the perimeter of the picture. So this is giving us extra information, trying to confuse us. So all we really have to do to find the perimeter is add up all the sides. So if this is 5, the side across from it, actually I'm going to see if we can do a different color. Let's do a different color. This side is going to be equal to this side, and this side is going to be equal to this side. So I'm going to use congruency marks here. And so 5 plus, there's going to be another 5, plus 7, plus another 7. Okay, and so we're going to get 10 plus 14, which would be 24 inches. And we don't square them because it's just perimeter. Now, if they wanted the perimeter of the frame, we'd have to add an inch. So an inch here and there. So this would be actually a total length of 9, and this would be a total length of 7. So it would get larger. So if I were to find the frame, which we're not, the perimeter of the frame that goes around it, we do 7 times 2 plus 9 times 2, which would be 14 plus 18. And we'd add those 2 together, and we get 32 inches for the perimeter of the frame. Okay? This is our correct answer because we're looking for the picture. Alright, so drawing pictures, remember? Always important. Okay, number 2. What is the circumference of a circle in terms of pi? What is the circumference of the circle to the nearest 10? Okay, so let's get started. Circumference equals pi D. What's the diameter? 15. What's the answer? It's 15 pi. Okay, when we have a number we like to put in front of pi. Should I put anything else on here? Yes. It's circumference, so we're going to put inches. Woo. Okay, and then round to the nearest tenth. I'm not going to do that right now, but all you do is plug in your calculator and round to the nearest tenth. Next problem. Alright, now we're finding perimeter again, this time in the coordinate graph. So, how do we find the perimeter? So we have to add up all the sides. Here's good luck, or good thing. We learned about distance formula 1.7, which means I could use distance formula for GF, distance formula for FE, and distance formula for EG. Here's the good news. If it is a perfectly flat line, we call horizontal, or a perfectly vertical line that goes up and down, we can just count. Okay? So I can literally just go 1, 2, 3, 4, 5, 6. So 6 is the distance from here to here. 1, 2, 3, 4, 5, 6, 7, 8. 8 is the distance from here to here. Okay? So that saves me time. I cannot count any lines that are diagonal. So what I have to do is I have to use distance formula. Okay? So I'm going to call this x2, y2. I'm going to call this one x1, y1. I'm going to write my formula. Whee! I still remember it from... What do I still remember it from? 7-1. 1-7. Not 7-1. We're not in chapter 7 yet. Okay. So we're finding the differences of the x's and the difference of the y's and squaring. Alright, so let's plug this in carefully. So we got 3 minus a negative 3. Notice how there's a negative embedded in the equation, and there's a negative with that x1 squared, plus 6 minus a negative 2. Again, that same thing happened. 2 negatives make a positive, that becomes 6 squared. 2 negatives make a positive, that becomes 8 squared. 6 squared is 36, plus 8 squared, which is 64, and oh my gosh, this is so lucky. You add them together, and we're going to get 100. Remember, all this was under the square root, so do not just write 100, because if this is a length of 8, you think that is a length of 100. Does that seem reasonable? No. Okay? Square root of 100, hopefully we know, is just 10 times 10 for the factors. So the two equal factors is 10. So we have 10 here. So to find the perimeter, we're going to take 10, 8, and 6, and add them up. And our final answer, orange. Should we go with orange? I'm going with red. Okay, 10 plus 8 is 18, plus 6 is 24. And then we can write units, because we actually don't even have to write units, but this would be our perimeter. We're talking about the coordinate plane, so they're not going to be in feet or inches. So, there you go. Okay, moving on. Okay, and here's our last one. Now, you notice that I did skip some problems I could have gone over, like we didn't even do an area problem for a triangle, a rectangle, or a circle. But some of these things are hopefully review for us. So I'm going to go out on a limb when we start our in-class assignment that we will be okay. And if not, then we will adjust and help. So let's take a look at this one. This one might be a little different to us. Okay, so what's the area of the figure at the right? All angles are right angles. Okay, well, we don't have a formula for this picture, so there's a couple things we can do. We can break it into figures we do know. Okay, so I'm going to break it up in a way, and I'm sure you could break it up in a totally different way, but I'm going to break it up right there and right there. So I created 1, 2, 3 different shapes. Okay, so the congruency pieces, these are all 3s, and that's a 9. Okay, so I'm not saying this is the best way to do it, I'm just saying this is the way I'm choosing to do it. To find area, we're going to do base times height. This is going to be a square right here, 2 equal sides. So all we have to do is 3 times 3, we're going to get 9. And we're going to get the same thing down here. And when I write inside the box, that's the area. So I hope you don't get confused with the 9, that's the centimeters on the outside. Okay? Now, we got to be careful on this box. It says 9 here, but 9 is the full length, but we cut off 3 of it. So the distance really, let's use violet. I don't know if I've ever used this color before. I don't know why. We take 3 off of 9, so this is actually a 6. And same thing here, this is 6. So 6 times 6 is the square here, so we're going to get 36. So I found the areas of 3 different pieces, kind of like the segment addition postulate or angle addition postulate. If I add them together, it should equal the full area of this shape. And so we're going to go ahead and get 9 plus 9 plus 36. And we're going to get 18 plus 36. And we're going to add those two together, so we'll get 10 and 30, that's 40. And then 54, I believe, is our final answer. And we are going to be talking about what unit? Centimeters. And then we're going to put a squared unit on there. Okay? So this is our area. Now, let me give you a quick lesson because I'll probably bring this up often in class. Let me read this for you the incorrect way first. Okay? This is how most kids read this. 54 centimeters squared. That's how they read it. That is wrong. That is not how it's said. Okay? This is how it is supposed to be said. 54 squared centimeters is how you said that, because they're square centimeters. So 54 square centimeters, not 54 centimeters squared. Think about your house or wherever you live, and you say, how big is your house? People would say, oh, I have a 1,000 square foot home. See how they say square first and then foot? They don't say, I live in a 1,000 foot squared home. No, because you're not squaring the feet. Okay, it's a square that is 1 foot by 1 foot, and there's 1,000 of them in your home. Okay, so this is 54 square centimeters. Alright, I think I'm done. I'm going to probably go game for a little bit, so peace out, people. If I can figure out how to turn this off. Where's my mouse?